Hi, everybody. It's Professor Mitchell. We're starting a new chapter today, chapter 6, starting with section 6.1 on experiments, outcomes, sample spaces, and events. In this section, we'll talk about experiments, trials, and outcomes, the sample space, events, special events, events as sets, and finally, we will define mutually exclusive events. An experiment is an activity with an observable result. Each possible result is called an outcome of the experiment. The set of all possible outcomes is called the sample space of the experiment, and an event is a subset of the sample space. So now we'll look at a few examples. In experiment 1, we're just flipping a coin. So a trial in this experiment would be one flip of the coin, and one possible outcome would be heads. In the second experiment, we're going to allow a conditioned rat to run a maze containing 3 possible paths. Trial would be one run of the maze, and one possible outcome would be that the rat takes the first path. And then the third experiment would be to tabulate the amount of rainfall in New York, New York in 1 year. So the trial would be 1 year, one particular year, and one possible outcome is 37.23 inches, right? Some particular amount of rain. All right, which brings us to the sample space. The set of all possible outcomes of an experiment is called the sample space of the experiment. So each outcome is an element of the sample space. In the last chapter, we talked about sets. So it just occurs to me that it might be helpful as we go along to tell you what the set version of each of these things is. So I'm going to go back here for just a second. All right, so the outcomes of an experiment are like the elements of a set. The sample space would be like the universal set. And then an event would just be a particular set, like set A, which belongs to the universal set or is part of the universal set. Okay. All right, so for an example of sample space, an experiment consists of throwing 2 dice, one red and one green, and observing the numbers on the uppermost face on each, the way that you normally play with a pair of dice. What is the sample space S of this experiment? Well, believe it or not, the sample space would be, each outcome of the experiment can be regarded as an ordered pair of numbers, the first representing the number on the red die and the second the number on the green die. So this sample space actually has a whole lot of outcomes in it. There they are. I always think it's tempting to think of the sample space for throwing a pair of dice as just being the numbers 2 through 12, because those are the totals that can come up. You don't want to think of it that way. And the reason is because, for example, rolling a 7 is not, I might be getting a little ahead of myself here, but rolling a 7 and rolling, say, a 3 are not equally likely. All right. So these outcomes are all equally likely. We'll talk more about equally likely outcomes probably in the next section. An event, E, is a subset of the sample space. We say that the event occurs when the outcome of the experiment is an element of E. For example, for the experiment of rolling 2 dice, let's describe the following events. E1 is the event that the sum of the numbers is greater than 9. E2 is the event that the sum of the numbers is 7 or 11. So when they say describe the events, they just mean list the outcomes that belong to each event. So if you look back at our list, it's pretty easy to determine which outcomes are greater than 9, which outcomes add up to 7 or 11. All right, so here it is. The outcomes where the sum of the numbers is greater than 9 are these 6 outcomes here. These 2 add up to 10. Actually, these 3 add up to 10. This one and this one add up to 11, and then this is the only outcome that adds up to 12. The outcomes where the sum of the numbers is 7 or 11, those are these outcomes here. So there are 1, 2, 3, 4, 5, 6 outcomes where the sum is 7, and an additional 2 outcomes where the sum is 11. All right, let's talk about some special events. Let S be the sample space of an experiment. The event corresponding to the empty set, remember we talked about the empty set in the last chapter, is called the impossible event since it can never occur. And at the other end of the spectrum, the event corresponding to the sample space itself, S, is called the certain event because the outcome must be an S. So here's a really simple example. Let's talk about birthdays for a second. The impossible event, so let's say I randomly pick a student in the class. The impossible event is the event that the student's birthday is on February 30th, right? Because February always has either 28 or 29 days. It never has 30. And the event corresponding to the sample space, that could be, oh gosh, let's see. Well, the event where the student's birthday is in January, February, March, April, May, June, July, August, September, October, November, or December. All right. It has to be in one of those, right? So that would be a certain event. All right, events as sets. Let E and F be 2 events of the sample space S. I was glad I looked this over before I started the video because there were some really bad typos on this slide. The event where either E or F or both occurs is designated by E union F. We talked about the union of 2 sets in the last chapter. And the event where both E and F occur is designated by E intersect F. And finally, the event where E does not occur is designated by E complement. All the same notation we used in the last chapter. For the experiment of rolling 2 dice, let E1 equal the sum of the numbers is greater than 9. Same E1 as in the previous example. And then this new event E3, the event that the numbers on the 2 dice are equal. So we're going to determine the sets E1 union E3, E1 intersect E3, and then the complement of E1 union E3. This might be a good time for you to pause the video, try this problem, and then come back and compare notes. All right, so hopefully you've tried that. Let's see how it turns out. So event E1, we did that in the previous example, right? It's got these 6 outcomes, sorry. E3, which is that the numbers on the 2 dice are equal. That's pretty simple, right? 1, 1, 2, 2, 3, 3, et cetera, et cetera. The union of those 2 events, you can list these in any order you want. Just make sure that you don't repeat any. In particular, don't repeat these 2 because these are the 2 outcomes that belong to both events. All right. And then the complement of E1 union E3, that would be the set containing all outcomes that are not listed here. So since there are 1, 2, 3, 4, 5, 6, 7, there are 10 outcomes in this set. the sample space has 36 outcomes. You can check that. That means that the complement of E1 union E3 would contain 26 outcomes. All right, and that brings us to mutually exclusive events. Let E and F be events in a sample space S. Then E and F are said to be mutually exclusive or disjoint. Those two terms mean the same thing. If E intersect F is the empty set. In other words, if the two events have no outcomes in common. If E and F are mutually exclusive, then E and F cannot simultaneously occur. If E occurs, then F does not, and if F occurs, then E does not. All right, let's look at these three events and determine which of them are mutually exclusive. All right, so mutually exclusive, remember, describes a pair of events. So E1, again, is the sum of the dots is greater than 9. E2 is the sum of the dots is 7 or 11. E3 is the sum of the dots on the two dice are equal. So again, I'm going to ask you to pause the video, think about this. Here's a hint. You want to think about, are E1 and E2 mutually exclusive? Are E2 and E3 mutually exclusive? And finally, are E1 and E3 mutually exclusive? All right, let's compare notes. Here are the outcomes in E1. Here are the outcomes in E2. So we look these over and see, do they have anything in common? I see right away that the outcome 5, 6 is in both, so is 6, 5. Since these two events have outcomes in common, that means they are not mutually exclusive. And then we look at E2 and E3, or if you just think about E2 and E3. So E2 is the sum is 7 or 11. E3 is the sum of the dot, or the two dice came up the same number, right? So these outcomes in E3 add up to 2, 4, 6, 8, 10, 12. They never add up to 7 or 11. So E2 and E3 are mutually exclusive. They have no outcomes in common. And finally, E1 and E3. E1 is the sum is greater than 9. E3 is the two numbers are equal. Well, 5, 5, and 6, 6 would belong to both of those events because these two outcomes add up to 10 and 12, which are greater than 9. So E1 and E2 are not mutually exclusive. E1 and E3, they're doing them in a different order, are also not mutually exclusive, but E2 and E3 are mutually exclusive. And that is going to do it for this section. The sample space of an experiment is the set of all possible outcomes of the experiment. Each subset of the sample space is called an event. We say that an event occurs when the outcome is an element of the event. The event E union F occurs when either E or F or both occurs. The event E intersect F occurs when both E and F occur. And the event E complement occurs when E does not occur. And finally, two events are mutually exclusive if they cannot both occur at the same time. And that's going to do it for section 6.1. We'll see you next time.